Right, so I know it's been a while, but I figured this one was worth a discussion. System controller problems with version 1 955s. Okay. Um, Two stories that I've heard. One is true, one is not. Um, the first one that's true, I'll go over that because it's the easiest one to knock out. U505 fails, and the radio goes into transmit, stays in transmit, can't reset it, can't get it out of transmit, just can't do anything about it. Bad U505. 100% true. U505 fails because of damage to the PTT line. Basically, the pull down MOSFET in U505 for that particular GPIO gets failed, gets zapped, what have you. The line is pulled down and you can't get it out of transmit. It's a bad U505, you must replace it. First problem with that is oh, you can't get it. If you need a U505, reach out to me. I could probably sort you one. Second weirdness about it is that supposedly C580 and 560 are like some kind of sacrificial caps or something. It's what I had a guy told me. I said, what? No. Oh, well, I heard it from an. Well, that's not the case. So L511 is a bead and C580, a 10 nano capacitor. These are to try to filter off the RF on the line. So there's a few culprits that cause this to happen that I've been able to deduce over years. Um, you get some RF into the PTT line, high RF environment, what have you, gets in the microphone cord, and boom, pops U505. Second one is like foot switches. You get some kind of static discharge in the PTT line from a foot switch, or from trying to make some kind of keying circuits or what have you that I've seen people try to make. They get them into PTT line, they kill U505. Once you sort whatever you did to cause U505 to fail, it's generally an honest to you. If you want something sacrificial, not these capacitors, because that's what they're for, then get a transient voltage suppression device, TVS device, parallel across C580. It could be your sacrificial component. And maybe it'll save you U505, maybe it will not. But generally speaking, it's usually something that's going on with the user system that causes it to fail. So that's true. Uh, this is where it gets more interesting. Second problem is this mode switching problem that supposedly the radio gets locked up in PA mode, which is, or the switch positions don't. You end up with some that go into PA, and that's another one that's not rooted in reality. Um, that does happen, yes, but it's not because of U505. It's actually because of another problem in the system. Um, So I've had two variations of the story told to me. One is that something happens on this PA and RSSI line, which actually has nothing to do with the PA system at all. Absolutely nothing. But that's why I had someone literally argue with me for about half an hour. Oh, it does. Oh, it does. Oh, it does. No, it does not. And so, if you want to be a muppet and argue about it, then be my guest. But I'm just not going to listen to you. I'm just going to hang up. So don't ring me with that nonsense. Um, so this is how the system controller U505 works. Communicates with the front panel over this data bus. You have RxD0, TXD0. Still simple serial bus. You got Con6. Well, that goes up to the front panel. Here's Con6, the other end of it. Here's your data line. And it comes in here to U3, which is just an MCS51 based microcontroller, one of these enhanced MCS51s, 8 of 51 microcontrollers. It's got like an ADC and some other things in it, which is what you see here. There's the inputs to the ADC multiplexer. And the one we're interested in is key 6. Key 6 goes over here to the mode switch. Says your mode switch. And as you can see here, 1, 1.5, 2, 2.5, 3, 3.5, so on volts. And if you have a bad position on this mode switch, it's going to default to PA mode or some other mode because something has happened with the mode switch and it's not making very good connection, what have you. I've seen both situations happen where one mode becomes another. It's a switch. So this is just, you got pull up with this 47K, you drop in, 12K, you end up with 1.5 volt at this point, and you've got your key 6 line. The microcontroller is going to see the volt or the 1.5 volt, depending on what position you're in. Over here on key 6, microcontroller U3 is going to send a command down to the system controller to say, hey, my mode switch has been moved to this position. and the system controller responds accordingly, sets the mode. So that's how that works. Now, when these two microcontrollers start up, you turn the radio on, they boot up, they start their applications, they do this simple handshake between one another. The front panel sends down to the system controller the position of all these switches. It's part of the handshake. Where are the switches? What mode are we in? System controller responds accordingly, sets up the front panel displays, the drivers, to display whatever they need to display. So that's how that works. And then the system comes up, and then everybody's happy. And then they're just happily sitting there talking to one another. Whenever the U3 needs to send some data down to it, like if you change the position of a switch, talking about the switches, not the knobs, not like the pots. You change a switch, it tells the system controller, hey, switch has been changed. System controller does whatever it needs to do. Do you have a situation where the front panel is sending a command to U505 and U505 is doing something else? That would be one I would love to see. I have asked around. There's no documentation of this ever occurring. It just doesn't seem to be anything that's rooted in reality. But I'd love to see it. Reach out to me, and I'd love to get my hands on that radio. I'd love to disassemble some stuff and take a peek at it, see what's going on. Especially if you don't have a bad mode switch and your U3 is sending the correct command, like you verify that with a logic analyzer. Just sniff the data bus and see what's going on. You can verify it's sending the correct command and interpreting it incorrectly at U505. That'd be an interesting one. I'd almost like to see that. Not saying it's impossible, but it would be the first documented case that I'm aware of this happening. So with that said, what is this PA and RSSI line that supposedly is caused the lockup or getting it stuck in PA? Well, this has nothing to do with PA. PA is actually this one. This is the PA. So for us to understand what PA and RSSI is, so we're looking at, note this particular system controller, okay? Now, let's look at this one, okay? So we have, these are the two variations of this board, okay? The one on the left is the one that's the most common, but the one on the left is not the radio that this drawing behind it is for. This drawing that you're looking at here that I've explained is for the one on the right. Notice the absence of this MOSFET. Notice that the L match is different and this low pass filter is different. Notice the differences. You can see that there's a lot of things that are different between these two versions. These are just two junk boards, one on top of the other, to show the two backs side by side. The one on the left is the predominantly most common. This is the one you're going to probably see 99% of the time. The one on the right, you're not going to see very often. The one on the right, you had this, then you had a version with this. This happens to be botched, ironically, into the PA and RSSI line, because this is a retrofit to change the behavior in some way, shape, or form of the TX meter. Okay. Notice that there's definitely some parts differences in layout on these boards. MOSFET's gone. It's the easiest way to identify the board. If you don't have a MOSFET, you've got a very early version of it. If you flip it over, you might have this on the back, maybe, but not necessarily. So this schematic behind it with the system controller is for the one on the right, not the one on the left. Okay, what about the one on the left? What's the diagram for that? Okay, that's this. You notice that this is a completely different looking drawing. We got some capacitors that have been added to these ADC lines. Again, PA RSSI lines. It's actually an input to an ADC. It's just measuring the voltage from the PA stage, which the RF power amplifier stage, or the received signal strength indicator, which is what RSSI is. So what about that MOSFET? Okay, well, that MOSFET is down here in the RF stage. It's right here. That's that MOSFET. Okay, now let's go over to this other drawing and let's look at its RF block. Notice the absence of the MOSFET in this section. Okay, see this blank area right here? These are 0 ohm resistors. Notice this blank area. We'll go over here. Well, There's your bodge right there. See, sampling from the PA stage. Goes on up, PA and RSSI, the RFPA stage. Now, what about the RSSI part? Because this is the PA part of it. The RSSI part of it is actually right here, and that is common between both versions. So you've got your AM, FM, RSSIs, receive signal strength indicators. This is your basically your S meter adjustments. And on this variant, it's basically the same thing. Again, this is the other end. This is the RSSI part. Now, where's the PA done? Now, we can look at that because it's pretty much the same between them. So we go over to the audio part. So this is the microphone audio coming in, mic amp. Notice these parts are actually not present on the newer version as well. If you look at the board, you'll see that these are DNP, do not populate. We got a switch, switches in and out the echo, got a little lamp stage, and this MOSFET right here, PA enable, sends the PA on out system. So that's how PA is switched on this radio. It's common between both radios. So no, this PA and RSSI line, they don't have anything to do with the radio being locked up in PA, or going into PA when you have the wrong mode, when you have the mode selected. Like say you had FM and it says PA instead. We got a bad mode switch. You know that's been basically every single case of the wrong mode being selected has been the switch. Or in one case, it was a resistor because somebody knocked one off and had someone to send me a picture of it. Hey, why does it do it? And I said, well, you knocked the resistor off. And it was like, oh, they replaced the resistor with the right value. It's like, oh, it works now. Of course it does. So nothing to do with the PA. Nothing to do with the PA. I don't know where the story originated. Don't care. Don't want to know. But that's how this works. Your modes are dictated here. Whatever you select here, just sends a command, system controller changes. Wherever any of this other stuff that's going on with this PA and RSSI line has nothing to do. I literally can't not understand why anyone would think that that's how that works, but stranger things, I guess. Now, with that said, again, you had a problem with the U505, you got a problem with the system controller on this radio, something doing weird. Feel free to ask. I've had lots of people who ask me this stuff, like how does this work? I don't have a problem talking about it. And I don't have a problem supplying any information if I have it. So again, avoid the mix-up also with the diagrams. Use the proper CPU diagram, system controller diagram for the proper variant of the radio. I just told you how you can identify them. Again, from this picture, old, new, color one, not color one. Easiest way to differentiate them is it because it's color, it's for the original one. If it's black and white, it's for the newer variants, which are the most common. Now there are some minor little changes in between them and so on and so forth, like the little bodge board and all that. But again, don't fall into the, well, my U505 is bad because it doesn't change modes properly. You need to be looking up here and discerning whether or not you have a problem up here in this mode switch or up in this divider. And whether or not you're getting the correct command issued down, because that, again, is where that happens. This is issues of command mode changes. So I hope that you found this helpful, and I hope this clears up how the system controller, a very, very coarse overview about how the system controller works and how modes are selected on the version 1 radios. Interestingly enough, it's basically the same on the version 2 radios. It's the mode switch with resistors or, divider, and yeah. It's pretty identical. So with that said, cheers, guys. Till next time. Questions and whatnot, put them in the little box under the video. And till next time, cheers.